Hey guys, welcome. We've got number 10. We have 2.50 grams of copper 2 sulfates dissolved in, what would that be, 900 milliliters of 0.3 molar ammonia. What are the concentrations of Cu2 plus and this complex ion and NH3, all three of them? Okay, so we will need a Kf value. So you have to look up Kf for this one. And Kf happens to be 5.0 times 10 to the 13th, which is quite large. Okay, so now we're starting off with 2.50 grams of CuSO4, which is soluble. And how would I know that? There's no Kf value or Ksp value for that. Right? And we're going to dissolve that in our 900 milliliters. And we know 1,000 milliliters is 1 liter. And we know that what? Well, copper is 63.55, right? Yeah, 63.55 grams per mole. Plus sulfur is 3207. Plus 4 times 16. So 63.55 plus 32.07 plus 4 times 16. I get 159.62. All right. And so if we do this math, we would do 2.5 divided by 9.0 times 10 to the 2 times 1,000. Divide 159.62. I get 0.0174. 0.0174, which really I have two sig figs, so it's right. Molar CuSO4. So really, that's 4 is extra, and that's just for rounding. But since this is soluble, that means we have 0.0174 molar Cu2 plus and SO4 2 minus. Now, the problem does not ask for sulfate. It asks for copper 2, the complex ion, and ammonia. So let's write out the equation. We have Cu right here. So we have Cu2 plus. We have NH3. And we have our complex ion of what? Cu NH3 4 2 plus. All right, so we're starting off with what? 0.0174, 0.30, these are molarities, and nothing. Well, we got the change. The change is going to be minus 0.0174 because we're assuming it's going to go all the way and then a back reaction. Minus 4 times 0.0174 plus 0.0174. So at equilibrium, we have 0, which, right, that's the problem. We're going to have to fix that, right, with a back reaction. We're going to have 0.3 minus 4 times 0.0174. which is 0.23, basically. And we're going to have 0.00174. All right, so now Kf expression would be equal to our complex ion of Cu, copper 2, NH3,4 tetramine over copper 2 in solution, which we have to solve for, and ammonia, NH3 to the 4th. All right, and so we're assuming we are solving for copper 2. We know what everything else is. All right, and so copper 2, it can't be 0. Right, so assuming a back reaction, right, you would have minus x minus 4x plus x, right? There's our back reaction. All right, and so you would have 0.0174 minus x, 0.23 minus 4x, and x. Well, let's look at this. 0.23 and k, let me rewrite it here. Oh, let's go back to the top. So there it is. K is 5 times 10 to the 13th. So that's -1 13th. So it's 14 orders of magnitude difference. So we can approximate. I'm going to write that out. We can approximate here. Approximate that change. And same thing with the complex ion. This 0.0174 is 10 to the -2. 1.7 times 10 to the -2, -13, or positive 13. It's way more than 1,000 times different. So you can approximate the change, right, both here and there to 0 or negligible, right? So what's going to happen, right, but we still have to solve for that x. So we're going to solve for that.
I found this on the web.
And now, rearranging Cu2 plus, right, would equal our CuNH3,4,2 plus over Kf times concentration of NH3 to the 4th. If that makes sense to you guys, hopefully it does. All right, so it's very similar if we just put in the minus x and the, well, this is actually, sorry, I messed up. It's a plus x. We're still approximating the change to nothing. So technically we would put this in here and this right there, and then approximate those change to 0. So I'm just going to shortcut the step. So Cu2 plus is going to equal 0.0174 divided by 5.0 times 10 to the 13th and 0.23 to the 4th power. So Cu2 plus would be what here? 0.0174 divided by 5 times 10 to the 13th, 0.23 to the 4th. I'm getting 1.2 times 10 to the -13th molar, which is very small. So that's an answer for copper 2. All right. Ammonia is what? NH3 is 0.23 molar. And our complex ion concentration, Cu and H3,4,2 plus, is equal to 0.017 molar. So these are our answers right here. All right. How did we get that again? Let's recap, because that's the important part, right? Not just coming up with answers, but how did we get to this answer? Okay, so what do? We had a soluble compound of copper 2 sulfate in a certain volume. So we had to figure out that concentration, which is what we did right there. Okay, but we put it into this guy. All right, and ammonia makes a complex ion with copper. We had to look up this Kf value. All right, so we did our chemical reaction of our free copper, right, because we don't care about the sulfate anymore, and ammonia making our complex ion. And so we did our ice table. All right, this is an ice table. I, C, and E. All right, and we assume completion, right? So we assume completion because Kf is large. All right, but this can't be 0 down here for copper 2. So we had a back reaction, and the back reaction doesn't really affect the concentration of the complex ion or ammonia in a measurable way. However, it does give some copper. And so we plug into our equilibrium constant expression, we rearranged, and then we solved, and then we just put everything in the concentrations. Hopefully that works for you guys. If you have questions, reach out. Otherwise, we'll see you in the next problem. Take care.